Hello everyone, this is Ankesh and today we are going to solve a question, create binary from description. So let's start with understanding the question. So in this the question is saying you have you are given a 2D integer array called description. Okay, so you have given 2D integer array called description. Okay, and in the description each element will contain like P of I, parent of I, child of I, and is left of I. Indicate whether P of I is the parent of child in a binary tree of unique value furthermore. Okay, so it is saying like every element in a 2D array will contain here three elements. This will be my parent and this will be my child. Okay, and if is left is equal to 1, then child is a left child of a parent. Okay, if here we have um, 1, then it means it will be a left child, and if here we have like 0, then it will be my right child. Okay, so what we have to do, we have to construct a binary tree described by description array. Okay, and return its root. Okay, the test cases will be generated such that the binary tree is valid. Okay. So in this, the question is saying you have given a 2D array. Okay, so you have given a 2D array in which, okay, you have given like 2D array like this, in which in each element you will have parent, you will have child, you will have is left, which will be either 1 or either 0, or either it will be 0. If it is 1, which means it's left child, and it if it is 0, which means it is right child. Okay. So what we have to do, we have to construct a binary tree. Okay, so in this we have to construct a binary tree. We have given parent, parent, child, and whether it is a right child or left child. Okay, and at last we have to return a node. Okay, so we have to return a node, root. Okay, so let's understand the question. So this was the first example given. So here we can say, wait a minute, so here we can say we have 20 is a, so here 20 is a parent, 15 is a child, so we can do 20. We can create a new node, mention 20, and then 15 as a new node, which is a left child. Okay, so what we do, we will create a 20 as a new node, we will create a 15 as a new node, and we will attach 15 as a left child of 20. Okay, in same way, we know we have 20, we have 17 as a new node, and this is my right child. For sure, what I know, this 20 and this 20 is same node. Why? Because it is mentioned in the question that bind tree of unique values, so every node will have a unique value. Okay, so what I know here is these are same. What I know, if the node is already been created, then I don't have to create a new node. Okay, so what I have to do, if a node is already being created, a node is already being created, We will not create new node. We will not create new node. Okay. Okay. And if the node is not created, then we will create a new node. Okay, makes sense, makes sense, makes sense. So how will we know whether a node is already being created or not? We can simply store them. Okay, so what we can do, we can use um key value pair, key value pair. We can say we can use hash map also. And if we encounter 20, what we do, we create we entered a key 20 and attach it with the new attach with a node 20. Okay, we again check whether 15 is present in this or not. So we see 15 is not present, we will add them in my hash map. I'll also create a new node. Now when I came here, I will again check whether it is present in my map. So I say, okay, it is present. So what will I do? I will use that node. Okay, I will use that existing node, and we will not create new node. Okay, so what we do? We just do is create. We will again check whether we have 17 or not. Oh, so we don't have 17. We simply put 17 and create a new node named 17 and attach them together. Okay, and it will be attached as a left child. Then again I have 50 and 20. We check first, do we have 50 in my hash map? I say I don't have 50, so I will simply add them. Create a node, create new node, add in my hash map. Okay, we will check whether we have 20. Oh, we already have 20. I will use that same existing node and make 20 as a left child of 50. In same way, we will see we already have 50. We don't need to create a new node. We see we have 80. We see we don't have 80 in my hash map. We will create a new node 80 and also added them in my hash map. So what will we know? We also have 80, which is attached to a 50 as a right child. After that, we will have 80, which is already been created. We would use that same node. And after that, we have 19. We don't have 19 since in the hash map. I will just create a new node attached as a left child and simply push it in the hash map. So, in simple word, we can say in hash map, I will have a pair of. Okay, so in simple word, I can say in hash map, I will have a pair of int, comma, node. Okay, I will have a pair of int, comma, node. Okay, since we know we have a pair of int, comma, node, mm, we will have since we are traversing through a description array, we will have all nodes present in this. We will have all nodes present in this hash map. So simply we can say I am using hash map hash map because I'm using hash map because first thing, if the node is already present, we don't need to create new node or attach child to new node. Like if the node is already present in Hashmap, we don't need to create new node. Hmm. If node is not present, then we need to create new node. Hmm. Or we can simply say, let's say in a hash map, if a node is present, which means simply we need to attach child to that node. We need to attach child to that node. Let's take an example. If in hashmap we have already have a 20 with a node 20, we will have a 20 with a node 20, which means we need to attach 20, we need to attach child to this already created node 20, not a new created node 20. Okay, it does make sense. Okay. So at last, I also have to find what will be the root of my tree. Okay, so in that case, we can say the 50 is the root of my tree. So how can we find? Let's say, let me just create this again. We will have 50, we will have here 20, here we will have 15, 17. Okay, okay. Here we will have 18, here we will have 19. So since this is a root node, in binary tree, okay, so a root node, we can say a root node is a type of node which don't have any parent node. Okay, it does make sense. A root node is a type of node which does not have any parent node. Then what we can do, we can just check we can just check whether okay, so in the array we can just check whether 50 is used as a child node or not. Okay, okay, since we can say here we don't have 50, 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 here we don't, we can definitely say this is my root node. Or more simple way we can do is, for sure we know we will don't have parent node. Okay, for a root node we will don't have parent node. uh, so what we can, so while traversing we are making okay, so while traversing we are making my tree, while traversing we are making my tree, we can also use one more hash map to store whether a node, whether a particular node has a parent node or not. Okay, for example, this 15, does does it does it have a parent node? Yes, it have. So I can simply put 15 with 1. Does the 20 have a parent node? Yes, it have. Does the 17 have a parent node? Does it have? 19 have a parent node? Yes, it have. Does it 80 have a parent? Yes, it have. Hmm. So we can simply, what we can do is we will create a hash map with int comma bool. For sure, I know 15 here 15 is a child root, which means it will have a parent root. So I can just put 15 have parent. Here I can simply say my 17 have parent. Here I can simply say my 20 have parent. Here simply I can say my 80 have parent. And now again here simply I can say my 19 have parent. The only node which is not present here will be my root node because it doesn't have parent. Okay, so I can say the only root which is not present, the only node which is not present in this hash map will be my parent node. Will be my root node. Okay, how will I find this? I already have a hash map which have all the nodes, so I can simply traverse in them and check whether this particular node is present in this node or not. Is this hash map or not? And if it is not present, I can simply say okay. If it is not present, I can simply say this will be my root node. Okay, 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 okay. Now let's move on to see the code and how it will work. Okay, so we will have an array, 2D array. We will have one our 2D array. This one. Okay. So here you can see we will have our 2D array. Okay, we will have our 2D array and okay. So what we will do here, I will create two two map, two Hashmap. Okay, one is MP, which will store my um value with node for tree construction. Okay, and another my has parent Hashmap which contain int with um boolean value which will which will eventually don't have my root node inside it. Okay, so here we can see I will start traversing with this. So in this example we can see in this will be my parent, this will be my child, and this will be my if left value. So here I can say 20 will be my parent, 15 will be my child, and 1 is my if is left value. Okay, so I created to pointer the child a parent node and child node. Firstly we will see whether 20 is present in my mm, hash map or not. If it is not present, I will create a new node. If it is not present, I will create a new node and put in the hash map. So if it is not present, I have created like this one. I have created my new node which is 20, and I will attach it here. 20 comma node. I can simply write 20 comma node 20. Okay. Okay. Again, I will see if 15 is present. Oh, it is not present. I will create a new node 15 and add as like this. 15 comma node 15. After that, this is for my parent, and this will be for my child. After that, we can simply check whether this is my left child or right child based on is left. If it is one, we know it is my left child. I will attach 15 as a left child of 20. Okay. Okay. I will attach, and I will also make sure to mark 15 as my parent. Okay. Again, I will go here. Oh, now I see 20 is already being present in my hash map. So I will use this already existing node, which is here. uh, 17 is not present. I will create 17 and insert this node in my hash map. So 17 new node is created and it is attached as right child, and also I will mark 17 as my parent node. Okay, same here we will do for all the elements in my description. So it will be like for 50 I will create new node 50 comma and comma 50. It is attached. So 50 will be attached to a left child on like this. So I can say 20 is also have my parent. When 50 is already being created, I so 80 is not created. I will do 80 comma node 80. Okay, so I have created 80, which is created as a right child. Okay, so I have to make sure my 80 also have a parent. Now I have 19. I will again push 19. Okay, like 19. Since it is not present, I will create a new node. It is attached to the left side of a array because here it is 1, and I will also make sure my 19 also have uh, parent. Okay, after that, what I know, the element which is not present in my has parent hash map will be my root node. Okay, so how can I check? I can simply check is 20 present in my has parent hash map. I say yes. Okay, is 15 present? I say yes. Is 17 present? I say yes. I say is 50 present? I say no. Since it is not present, it will be my root. It will be my root of the binary. Oh, I'm right. I can just return the node 50. Okay, so here you can say this is what I am doing here. I have created a root node with a null pointer initially. I am iterating to my MP if as I'm checking if every element present in a has parent or not. So we will see the 50 is not present. I will make 50. So I will have 50 comma node 50 which is not present. So I will make root as a node 50 pointing which indicates IT of second. Okay, then I will return. I can also use break here. Make sure to use here break here so it will not go for more we can say more values. If here we find 50, then it should be returned. Okay. Okay. Let's see how it looks like. Okay. Okay, it is submitted, and the time complexity for this will be like the time complexity for this will be like mm, O of n plus O of n. This is for traversing through description, and this is for traversing through MP will be equals to O of n. The time complexity will be of n, and the space complexity will be of 2n, because we are using two hash maps, one for creating a tree and another to check whether whether parent is present, or we can say simply to find a root element. Okay. Okay, thank you. If you like this video, let me know in the comment section.